Okay, so we are back again with our lessons as usual, and we are looking at the mechanics. Subtopic is linear motion, and under linear motion, you're going to look at distance covered in the nth second. They always set a question that asks you, find the distance covered in the 30 second. We want to see how do we really do this. So with this, we shall now say solution, or maybe we can just read through the sake. A particle moves away from point O with an initial velocity of 0.25 meters per second. So as per this, I will say solution. Initial velocity U is 0.25 meters per second. The particle travels in a straight line and accelerates at 1.5 meters per second. So the acceleration of the particle is 1.5 meters per second squared. Please, the SI units, must pay attention to them. And accelerates at 1.5. Okay, find the distance. Find the distance. We told the distance is the same as displacement. You can go in lesson 1. We did all of that. Distance is the same as displacement. Okay, because distance is a scalar, displacement is a vector. Distance covered by the particle during the 30 second. Now, whenever they say 30 second, you all know that the word second means you are dealing with time. So, what you're going to do here, we have given us the time in advance, but then what are we going to do? I will come here in my side work. I'll come here in my side work and show you what we mean by 30 seconds. So if they say 30, okay, second, what do they mean? 1. What you do, you come and say, here, we shall consider what we call a plus or minus 1. So when you're considering a plus 1, it means that when you're considering a plus, okay, if you were to consider this one third, let's say for example, we may have, okay, we can say use, for example, this is okay, 0, 1, 2, 3, 4, like that. Let me use this logic first of all. 0, 1, 2, 3, 4. Now, this means that if you look at this and this, these are positions. Then if you look at this and this, this and that, this and that, this and that. Now, it means that this one here, we call it first. This one here, we call it second. This one here, we call it third. So it means that whenever you have a 30 second, it means that you're going to take when time is 3 or when time is 2. And the simple logic I was speaking here is, we shall consider here a minus. First of all, at 30 second, we have a 3 itself. Then a 3 minus 1 is 2. So at 30 second, this 3 means when time small t is equal to 3. And this 2 means when time small t is equal to 2. That's the simple logic we shall use. So it means that when they say 30 second, so say for example, okay, time here, they've given us third. And this third means you're going to consider when the time is 3 and when time is 2. So now we shall come and say, now we shall say that the distance covered in the 30 second, is the same as the distance covered when time t is 3 minus the distance covered when time when time t is 2. Why we say the third? Third means third is here, so it takes on 3 and the 2. Or you can say 30 second, you maintain the 3 when t is equal to 3, then minus 1 when t is equal to a 2. So therefore, shall say we need this S3 and S2. Let's get S3. So using S is equal to U plus UT, S is equal to UT plus a half AT squared. So now I shall say that S is equal to, what is our U? S3. By the way, let's get S3. S3 is equal to, S3 means the time it is equal to 3 here. Means the time it is equal to 3 here, means the time it is equal to 2. Okay, so substitute, this will be a 3 times, what is our U? Our U is 0.25 plus a half times 1.5, which is the acceleration, times, okay, 3, but squared. Now we shall report S3. S3 will be what? In meters, like that. So we now get our calculators and press very fast. Get our calculators and press very fast. And when you press, you realize that we shall get this one squared. Okay. we shall come up with 7.5 meters. When you square this whole stuff, you get 7.5 meters. Then also come and get SRT2. SRT2 will be, all right, A2 times 0.25 plus a half times 1.5 times A2 but squared. Now what will be your SC2? Your S2 will be that the displacement covered when time t is equal to 2. What will be our S2? And when you look at that, all right, our SC2 is going to be a 3.5 meters. Please use a calculator to get those answers. A 3.5 meters. But our final answer must be the distance covered in the 30 second. So I'll come and say the distance covered in the 30 second is equal to the distance covered when the time it is there are 3 seconds minus distance covered when there are 2 seconds. And this will be a 7.5 minus a 3.5. Is it so? Yep. So distance covered in the 30 second is equal to 4 meters. And with that, you will have successfully answered that. Okay, question. Okay, let's now mature a little bit. Here we are. Now we shall be using the same details. They want to see which distance will it be when it is in 4th second. So 4th second here we shall say solution. Still we're going to use the same logic. We know that our u is remaining and it is 0.25 the same meters per second, and our a is 1.5 meters per second squared, and our s, okay. Anyway, now they are asking for the distance covered, which is the displacement. Now let's see the analysis when it is 4th second. 4th second. Now I said I'll use this side work again. I said that 4th second, when it is the 4th second, we do like this: maintain the 4, then this minus 1, 3. So that we're going to calculate when time it is equal to 3 and when time it is equal to, rather, time it is equal to 4 and time it is equal to 3. So shall I say, I'll use that logic. I'll say now the distance covered in the 4th second is equal to the distance covered when the seconds are 4 minus the distance covered when they are 3 seconds. Please, I'm taking the logic from here. You maintain the very digit, then minus 1, you put this one, then it will work. Or if you don't want that, I said, it can be 0, 1, 2, 3, 4, 5. Now you come and number. This is first, this is second, this is third, this is fourth. You see that fourth is here and it takes on 4 and 3, which you already have there. And now, shall I proceed? This will be, okay, let me get SRT4. SRT4 will be equal to, I'm still using the second equation of motion. SRT4 is equal to, okay, UT, I'm using this equation here. UT, so the U is 0.25 times 4 plus a half times 1.5 times 4 but squared, of course, the time. What will be the distance covered? The distance covered when time it is equal to 4 seconds. And it will be S4 meters. When you press on the calculator, we shall have it as SE4. SE4 is giving us 13 when you square very well. So S4 is giving us 13 meters. Okay, good. Now let's go and get SRT3. SRT3 will mean the initial velocity times the time, which is 3, plus a half times the acceleration, which is 1.5, times the 3 squared. So SRT3 will be equal to, now the SRT3, we already had it. Even if we don't press the calculator, SRT3 was 7.5. So SRT3 was 7.5 meters, like that. And now that means the distance covered during the 4th second is equal to, we say the SRT4, that is 13 minus 7.5. So therefore, S covered at the 4th second, the displacement covered in the 4th second is 13 minus 7.5. Back to the calculator, the answer you will have is 5.5. Please use your calculator and see which answers come up afterwards. So you must be in a position to calculate the distance covered in the 4th second, in the 8th second, in the 10th. Now your trial is here. For you try out Roman number 3. Distance covered in the eighth second. Okay. You will try that out, distance covered in the 8th second. And I think, let me as well quote for you the answer. The answer will be 11.5. Please try out this one here. The answer should be 11.5 meters. That's how it is. Now, in another question, they may give you that the distance in the 4th second is this. Learn how we treat the 4th, 8th, 10th, depending. Okay, let's still proceed. Okay, so we have another example again. And it says, a motor car started from rest. Please, you must underline that. So when they say solution, so when they say a motor car started from rest, means that the initial velocity is equal to 0 meters per second. Started from rest. Those terminologies were defined or explained in lesson 1. Go in the playlist and look at the first lesson there. Moving with uniform acceleration, goes 9.5 meters in the 10th second. Goes 9.5 meters in the 10th second. After starting, we stop. Find the acceleration of the car. Now we must come and analyze. We must come and analyze here. They want the acceleration of the car, so we don't have acceleration of the car. Have they? Okay. All right. So come and analyze. When they say in the 10th second, our analysis said we have to get two values of t here. The first value of t is the 10 itself. When t is equal to 10, then the other value of t is minus this, minus 1. 10 minus 1 will be the other value of t, so t is equal to 9. Then we said that then the distance covered in the 10th second will be equal to the difference between this and that. So the difference between the S10 minus the S10 minus the SC at 9. But remember, the S10th itself, the S10th, the distance covered in this, they've given it to you as 10. You must quote the language very well. The S10 has been given to you as, this S10 has been given to you. So now the equation we're going to use, we shall now come and say, allow me use this area, so shall I say that S10th will be equal to the S at 10 minus, please 10th is a position, but S at 10 means that time it is, okay, minus time it is 10 over, rather minus, this one is 9. Now we are using the second equation of motion, that is S is equal to ut plus a half at squared. We are using this equation, S is equal to ut plus a half at squared, like that. Now what we are going to do, we shall now come and say, now what is at S, I'm going to subtract at once. S10th is 9.5. Please learn that. S10th, the distance covered in the 10th second is this, meaning that after subtracting each and everything, it was this. The S10th is equal to 10, but what does S10th tell us? This minus that. Therefore, the 10 must be here. Then you start substituting the values for that area. So we are using the equation S is equal to ut. U is what? U is 0 times T is 10 plus a half times A. A we don't have, it's done, they want us to get, times now the 10 but squared minus, now I'm at this, so that will be, the U is 0 times, all right, the time is 9 plus a half, I'm using this equation, half times the A, which we don't have, times the 9 but squared. All right, let's now harmonize. This will now be 1.5 is equal to, let's harmonize this area here. This will give us 100 divided by 2. There we shall get a 50A minus 50A minus. Let's now proceed. So here we shall now get 81. Shall get 81 at that level. And now on our calculator, when you divide, say 81. All right, 81 divided by 2. It will be 40.5. It will be 40.5. So it will be 40.5A. 40.5A, like that. When you subtract, you shall have 9.5. 9.5 is equal to, subtract these two guys, you will still get 9.5, but A. Remember the word acceleration, so divide by 9.5, then even here divide by 9.5. Cancel that and that. Okay, we shall have our A as 9.5 divided by 9.5 shall get 1 meter per second squared. Please, the SI unit, a high record 4. All right, so we are still proceeding. We have now another question. That is another example, the last one. As far as the calculations are concerned, the next topic will be, or rather, the next part of this topic will be the graphs, and we shall step into them. So we have a particle traveling in a straight line with a uniform acceleration. I told you whenever I see this word uniform acceleration, just know you're going to use the other three equations of motion. Covers distances x and y. Covers distances x and y in time in the third and fourth seconds of motion respectively. Respectively means that the third goes with the x, the fourth goes with the y. Okay. Respectively, a full stop. Then the saying show that the initial velocity is given by, okay, show that the initial velocity is given by that. It's now a proof, and in mathematics A level, the proofs are just something very simple. Okay, now let's a solution. Now as a solution, let's pick out the meaning of the words we have. Like, say for example, they are saying the distance covered in the 30 second is equal to x. Okay, because they say that x and y in the times of third and fourth. So therefore, the distance covered in the 30 second is that. Then also shall come to know here that what the distance covered in the fourth second. Distance covered in the fourth second is what? Is x. Rather y is y. Is y. I'm treating the two separately so we can know where we going to go. So now we have s third. Remember we said that when it is third, we shall take a 3 and a 2. So this means that s third alone means s at 3 minus s at 2 must give us that x. You can see that. Same way here. If you have fourth, the 4 will remain, then minus 1, 3. So that s fourth will be the s at 4 minus the s at 3 will give us the y. That is it. Do you have any value which is known? No. And you see that this one remains as u. So we shall use the second equation of motion. So using s is equal to ut plus a half at squared. So substitute. Let us substitute. And we see the way forward. Okay. So this will be, okay, what should we do? Should we first of all get one by one, then we substitute later? Okay. Let me get s at 3. So s at 3 will be equal to 3u, of course I'm substituting here, plus a half times a. We don't have a also. Times, okay, but 3 squared here. Like that. So now, what will be our s at 3? Our s at 3 will be 3u plus, harmonize here, this is 9. 3 squared is 9 divided by 2 will be 4.5. So 4.5a. That is s at 3. You already have it. Now what you're going to do, I want now harmonize. I want to sort out this part. Allow me to transfer this side. Allow me to transfer it to this side. So this is now s fourth is equal to y, but s fourth means that s at 4 minus s at 3, which is equal to y. Please don't use this area here. Now that will mean that, now here what I'm doing, I'm first of all finding s3, then I find s2, I bring them together and I subtract. So now let me find s2. So the s2 will be equal to, I'm using this very equation, u is 2u, of course u times t is 2, okay, plus a half times a times 2 squared. So now s at 2 will be equal to 2u plus, harmonize there, we shall get, I think, 4a, not 4a, but 4 squared divided by 2, that is a 2a, like that. Now, you see, we have s3, then we have s2, but to get x is equal to this minus that. So therefore, we come and bring back this, that s3 minus s2 gives us this guy of ours, who is x. So now, substitute, this will be now a 3u plus 4.5a minus brackets, minus s2, brackets, which is a 2u plus 2a will give us x. Let's harmonize. This will be, all right, 3u plus 4.5a minus 2u minus 2a equals to x. Let's connect items and subtract. 3u minus 2u will just give us a u plus 4.5a minus a 2 will just give us a 2.5a is equal to x. And please allow me call this my equation 1 after thorough simplification. We now come back to this. So with this, we shall say, let's now get SRT4. SRT4 is equal to, I'm using this very equation, ut, which will be 4u plus a half a. Now, why I'm using u and a, I've not defined them in the question, so leave them the way they are. So times, okay, now SRT4, that is 4 squared. Now SRT4, what will it be? Shall I have now a 4u plus. Now this is 16 divided by 2, that will be 8a. So SRT4, we have it. We already have SRT4. So we have SRT4, and now I want to get SRT3. So SRT3 will be equal to, okay, 3u plus a half times a times 3 but squared. But if you look at this, SRT3 resembles this one here. SRT3 is the same as that. So with the super, after simplifying, SRT3 will give us a 3u plus a 4.5 and a, like that. So what next? Let's now bring in, we substitute and simplify. So let's substitute. Let us substitute. This will now be that we know S4 minus S3 gives us a y. So now S4 is a 4u, it is here 4u plus 8a minus bracket, I'll bring this, 3u plus 4.5a is equal to y. Let's add. So now that will be 4u plus 8a minus 3u minus 4.5a. Sorry, there is a here. 4.5a is equal to y. You collect like terms, subtract, so you can have a fine equation. So 4u minus 3u will just give us a u plus 8a minus 4.5. That will give us a 3.5a is equal. Please use a calculator. Now here, if it is 8a, you can just write it as 8 minus 4.5. Then the answer you get to attach a is equal to y. So this one here is my equation number 2 after super simplification. Now we shall say solve 1 and 2 simultaneously. Shall now say this is that. Shall now say solve equation 1 and 2. Solve equation 1 and 2 simultaneously. Okay, and solving simultaneously, I'll bring them together, and this will be, shall have u plus a 3.5. I'm starting with equation 2a is equal to y, like that. Then, okay, this one is u plus 2.5a is equal to x. All right. Now, all right, which method are we going to use? Remember, they just want us to find the value of u, show that the u is equal to that. So what should we do? Okay, it means that we should do, which one should we eliminate? First of all, which one should we eliminate? You look at that, which one should we eliminate? All right, so now here I think one would think of eliminating u, so you can remain with the a. That also can work, but okay, eliminating u, then okay, let's eliminate u. Now eliminating u, then we shall substitute later for a. It will just subtract. So u minus u will give you a 0. Then you can say 3.5 minus a 2.5. 3.5 minus a 2.5, so this will give you 3.5 minus a 2.5, that will give you, all right, I think it will just give you a. So a will be equal to, remember this one must be y minus x. Like that. Please, you try on your calculator and see. A 2.5 minus 3.5. Yep, I think it is just that. So if our a is equal to this, I'll call this one equation star. Why I call it equation star is because I dislike issues of saying equation 1, equation 2, equation 3, up to even equation 10. I prefer using star. Now, if a is this, now put in any equation. We shall put now maybe in equation 1. Put in equation 1. Whereby our equation 1 is u plus 3.5a, okay, is equal to y. So from, shall I say from this. Now it will be now u plus substitute, where a is so 3.5. But now a 3.5 is same as what? A 3.5 is same as a 7 over 2. You can look at that. When you convert this into fraction, 3.5 is same as 7 over 2. Now you bring in the a which is a y minus x is equal to y. A y minus x is equal to y. Now what you're going to do, is, let's multiply through by 2. Multiply through by 2. So multiplying through by 2, this will give us, so here it means that times 2. All right, even here times 2, even here times 2. That's the meaning. Now that will be, okay, 2u plus, okay, 7 into y minus x is equal to 2y. We want to see, will the proof come out? If it fails, we say, yeah, it has failed. Anyway, but it's really hard to fail. This kind of question is a simple one. So we shall now say 2u plus 7y minus 7x is equal to 2y, like that. Collecting like terms, let you have to remain with u as a subject of the formula. Let this other go the other side. So it will be 2u is equal to, this guy is already waiting, the 2y. Now when this one comes over, it will be minus, it comes over, it will be a minus a 7y. When this one comes over, it will be a plus 7x, like that. So you have 2u, which is equal to, subtract here, give us a negative 5 and y plus a 7x. All you need is just to correct the arrangement, then you have it done. So it will mean that you have 2u is equal to, start with a positive value, 7x minus a 5y. Therefore, divide by 2, divide by 2. And with that, I guess everything will be okay. Cancel this and that. Then you realize that your u will be equal to, now this over 2 means just a half brackets. Okay, we have here a 7x minus a 5y as required. Please don't forget to subscribe.